Day 2 of section 314, we're going to be working on pages 10 and 11. So at the top of page 10 is question 36. It says, Darren is a Democrat and is really hoping that a Democratic candidate will win at least one of the offices. Darren tells his friend Antonia, since the Democratic candidate for governor is supported by 53% of the voters, and the Democratic candidate for Attorney General is supported by 37% of the voters, that means 90% of the voters support the Democratic candidate for governor or Attorney General. Antonio says, well, that is true, then 101% of voters support a Republican candidate for governor or Attorney General. Is Daryl's thinking correct? He is not correct. He needs to realize that there were the overlapping parts. Remember when we shaded the column yellow and we shaded the row orange? The overlapping part would need to be subtracted out. And can you have 101% of voters vote? Only if somebody's cheating, right? 101% is more than all of the voters. Okay, so 101% is not correct. Okay, any questions on part A? Oh, and I forgot to highlight that. Part B says, the union of two events, A and B, is the event consisting of all outcomes that are either in A or in B or in both events. What outcomes from the sample space are in the union of the events Democratic governor and Democratic Attorney General? How can this be seen in your area model? So if you turn back one page to page 9, down at the bottom, down here, where we did the column for Democrat and the row for Democrat, it's all of those, okay? So this one would be DR, DD, DO, and the other one would be, so here they are listed, DR, RD, DD, DO, and OD. Okay. What does the O stand for again? Other, right? Not everybody's voting for a Republican or a Democrat. O is for other. Okay. Part C says, what is the probability of the union of the two events in Part B? That is, what is the probability that a randomly selected voter supports the Democratic candidate for governor or the Democratic candidate for Attorney General? Okay, so from the area model, we're going to add up all of the numbers that were in these boxes. Okay, so there, if you flip back over to the previous page, you had a 0.3233% or decimal, plus 0.1961 decimal, plus 0.0106 decimal, plus 0.148, plus 0.0259. If you take your calculator and you add all of those up, you get 0.7039, which is your decimal answer. But as a percent, you need to multiply it by 100. It's the same thing as moving that decimal point 2 places to the right. So it's 70.39%. Part D says, what is the probability that a randomly selected voter supports a Republican for governor and a Democrat for Attorney General? So if you flip back over, Republican governor and Democrat for Attorney General, that box or their intersection, it has 0.0 148. So you write down 0.148. You multiply that by 100. That's going to be 14.8%. So you just see where they intersect. Part E. What is the probability that a randomly selected voter supports a Republican for governor or a Democrat for attorney general? So from the area model, we add up all of the decimals in their shared boxes. We get 6 point, I think that's a 2. Yeah, because it's a 2 over here. I'll fix that. 0.622. Multiply it times 100, and you're going to get 6.22, 62.2%. Let me rewrite that too. There we go. A little bit nicer. Okay. Question number 37 says, Viola described the following methods for calculating the probability in part CE of problem 36. I shaded all the outcomes for a voter preferring a Republican governor and all the outcomes for a voter preferring a Democrat attorney general. But I noticed that there were some outcomes that were shaded twice. So I just added the original probabilities and subtracted the probability of the overlapping outcomes. So instead of adding each of the boxes, she started with the 0.4, the 0.37, and then subtracted the overlapping. So if you turn back to page 9, you're going to see at the top of this column is where she got the 0.53. And to the left of this row is where she got the 0.37. Add those two together and then subtract out the overlapping, which was 0.1961. And that gets the 0.622. Okay? So part A says, does Viola's answer match your answer for part E of problem 36? How does her method compare to the methods you used? We're going to say that the answers match. We got 0.622. She got 0.622. So the same answer, but she did the whole column plus the whole row minus the overlap. Whereas we just took all the boxes and added them together. You're going to get the same answer. It's just done a slightly different way, and it's really just preference. So which way do you like better? All right, part B down at the bottom says, will Viola's method always work? Why or why not? Yes, it will always work because you can just add all of the events and subtract any overlap that you might have. Any questions so far on question 37? Anybody still writing? Okay. Give you just a second to catch up. Good? Okay. All right. Flip over to the top of page 11. And now we're on question 38. It says, Viola's method of adding the two probabilities and subtracting the probability of the overlapping event is called the addition rule and can be written as the probability of A or B is equal to the probability of A plus the probability of B minus the probability of their union, A and B. You have already seen that any event where event A or B occurs is called a union and is said A union B. The event where both events A and B occur together is called an intersection. Best example of it is on page 9, where we shaded the column and the row, and we had double shading in their overlapping. So the addition rule can also be written as the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A and the intersection of B. Use the addition rule to calculate the probability that a third party candidate will be elected to either governor or attorney general. Then check your results using another method. Okay? So if we use the addition rule, we're going to add the other column, 0.07 plus 0.02. So if we flip back to page 9, on page 9, the other column was 0.07, the other row was 0.02, and their intersection would be this box right here. So we have to subtract that out because that's their overlap. So we say 0.07 plus 0.02 minus their overlap, and we get 0.0886. The other method is just to add all of the boxes. So if we go in the column going straight down, we get those three, and then we go in the row, we add those two, but not this one because we already added it. Okay? Notice that we get the same answer, 0.0886 and 0.0886. So either method will work. Let me shrink it just a tad. There we go. Okay. Question number 40 says, sometimes it is easier to figure out the probability that something will not happen than the probability that it will. When finding the probability that something will not happen, you are looking at the complement of an event. The complement is the set of all the outcomes in the sample space that are not included in the event. Show two ways to solve the problem below. Then decide which way you prefer and explain why. So for part A, it says the marketing department has interviewed people of all different age groups about the barbecue chicken salad. But now they need information about why the other salads are less popular. What is the probability that the next person randomly chosen will not prefer barbecue chicken salad? So we say the probability that they will not like the barbecue, you fill in all of the boxes, add them up. Or the other way is to start with 1 and subtract the probability that they do like the barbecue. You end up with the same answer. You end up with 0.4 and 0.4, which is roughly 40%. You multiply those by 100, you're going to get 40%. So if the probability of an event is represented symbolically as the probability of an event happening, or a probability of A, how can you symbolically represent the probability of the complement of event A? You're going to say 1 minus the probability of the event happening. Finish copying that down.